AT1. You have a calculator. Here we go. So you have each cross-section perpendicular to the x-axis is a semicircle. When you have cross-sectional volume, you have either perpendicular to the x-axis or perpendicular to the y-axis. This is perpendicular to the x-axis, so I'm going to draw what that means, and then realize that that is telling me about one of those rectangles that we learned from the very beginning of what is an integral. Now, when you're dealing with cross-sectional volume, your goal is, what is the area formula, and I'm going to integrate it. That's your goal. Second issue, though, is with respect to x or with respect to y. If you are dealing with perpendicular to the x-axis, then that means your tiny, tiny cut up into small bits are your horizontals. You have a bunch of severely thin rectangles where the vertical distance will be found, but that horizontal distance is super, super tiny. This is dx if it's a horizontal cutting up. That means your area formula must be in terms of x, and it must be from x equals a to x equals b. Now, with that said, we know where we are with respect to x. The next thing that I'm looking for is, what is this area formula? They told you semicircle. So either you remember how to deal with a semicircle, or you think about the geometry of semicircle. The diameter of that semicircle is this vertical distance. So if you know the diameter of a semicircle, what is the area? Well, you know the area of a full circle is pi r squared. You know that a semicircle means half of that pi r squared. What is the relationship of diameter to radius? The radius is half the diameter. Now, you can put it into this format, or you can simplify the formula. This formula simplifies to, in the denominator I have this 2. This 2 is squared. That makes 2 cubed, 8. So pi over 8 times the length of the diameter squared is the formula that I want to use for my area formula. So pi over 8, length of diameter squared, it's a dx. And actually, as I look at it, can I see the endpoints of my x? Does it look like it's negative 2 to 2? You can be certain if you take a good look at this. You do have a calculator. So, but if you don't have a calculator, what you want to realize, well, okay, let's say it this way. Your x-intercepts are happening when your y is 0. Put in y equals 0. What are you going to get? You're going to get plus or minus 2 for x. Do you see that? If that is 0. So that's how you can know for sure. Now, your next order of business is to come up, or your last order of business is you need a formula in terms of x for the length of each diameter. And that diameter is a top y value minus a bottom y value. And those y values are based on this equation. But if you need to know the y values, you need to isolate y. So I'm going to take this equation. I've got y to the 4th over 81. I'm going to subtract x to the 4th over 16. Then I'm going to multiply by 81. And then I'm going to fourth root the whole thing. And if you even root, what happens when you even root an equation? You got that plus or minus. So that means this is positive, the fourth root of that lovely stuff. This one is negative, the fourth root of that lovely stuff. If you take the positive and you subtract the negative, do you see that you actually get 2 times that? So you can either go the long way and write this minus negative this, or you can put into that subtraction 2 times the fourth root of all that lovely stuff. And after that, it's a calculator, throw it in, and get an answer. And the bell rang, so dun, 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 dun. Stop the